These are the frequently asked questions for Algebra 2, Section 8.5, Day 2. I'm going to start with number 24, and these are complex fractions, which again means that we have a fraction within a fraction. So we have 2 over x plus y, and we are supposed to divide that by 3. But we know that we do not divide fractions, we multiply by the reciprocal. So 2 over x plus y times 1 over 3, because this would be like a 3 over 1, will actually give us what we need. There isn't anything here that we're going to be able to cancel or cross-reduce. So we will have 2 times 1 for our numerator, and then 3 times the quantity x plus y for our denominator. So that one's just getting us to work with a very basic example of a complex fraction. Not a lot that we could do with it, not a lot of manipulation. Then with number 28, we have 2 divided by x plus y, and all of that is over 5 divided by x plus y. So what we have to do is multiply by the reciprocal. So there's the numerator, that one doesn't get flipped, but the one in the denominator absolutely gets flipped, which gives us some good news here, because that means our x plus y's are going to cross-reduce, and we will get 2/5 for the fraction for number 28. So a good example there of when really nice things start to happen and drop out when you're dealing with a complex fraction. Now number 29 is going to take a little more work. And that's because I have 3 over x minus 4, but for my denominator, I have to get a common denominator so that I can put those two pieces together. So I have 3 over x minus 4, that's just going to have to wait for a minute while I deal with 1 minus 2 over x minus 4. So first thing to see here is that our 1 is really 1 over 1. Second thing would be change that to adding a negative. You don't want to lose track of any negatives as you go through this process. Now what I'm going to do is just focus on getting my denominator to be 1 fraction. And I realize the LCD for this is going to be x minus 4, so this first fraction is going to need to be x minus 4 over x minus 4 plus a negative 2 over x minus 4. Now I have a common denominator, and I can go ahead and put these two pieces together with addition. So x, nothing else across the numerator, minus 4 plus a minus 2 is going to be minus 6 over x minus 4. Now that is what I'm going to use for my new denominator. So what I will have when I do that is 3 over x minus 4 divided by x minus 6 over x minus 4. And now I have 1 fraction divided by 1 fraction, and I can go ahead and multiply by the reciprocal. So this will be 3 over x minus 4 times x minus 4 over x minus 6. And my parentheses need to go all the way there. And we can see that the x minus 4s are going to cancel out, and that will leave us with 3 over x minus 6. And that will be our answer for that one. So there was another good example of how we have to get 1 fraction divided by 1 fraction so that we can change it to multiplying by the reciprocal. Now, next question. This is, well, part A is not so bad, but part B is kind of a doozy. So for part A, it says your car gets 25 miles per gallon around town and 30 miles per gallon on the highway. Now that should take you back, a little flashback to the problem that we did in class for problem 5. Now in problem 5, the example we did in class, it said that they travel the same number of miles. And this one for A says 50% of the miles you drive are on the highway and 50% are around town. And so that fits perfectly with what we did in class. We don't know how many miles they're going to drive, but we have miles for the SUV and we have miles for the hybrid. Or in this case, it would be for the car that gets 25 miles per gallon around town, and then the same car getting 30 miles per gallon on the highway. So we're really just saying there's going to be some miles at 25 miles per gallon and there's going to be some miles at 30 miles per gallon. We don't know how many. So what we have to do is remember that we do know how many miles per gallon they get. Whatever miles they have for the first vehicle, you're going to divide that by 25 to get the miles per gallon. And then for the second vehicle, you're going to take the number of miles, which is the X value because we don't know it, and you're going to divide it by 30. And that's because that car gets 30 miles per gallon on the highway. So now we have town and we have highway taken care of. So on the top, it's the number of miles that you're going to spend doing basically two different types of traveling in your car. One is for your town miles and the other is for your highway miles. And the same thing below that. You know, we're trying to figure out, well, how many gallons would you use if you're using this car in town, and how many gallons would you use if you're using this on the highway? So the next piece is we have to figure out a common denominator so that we can put those two fractions, x over 25 plus x over 30, together. So what we need to do is think least common multiple for 25 and 30, and whether or not you do this in your head or with your calculator, you're going to realize that's 150. So this first fraction will need to be multiplied by 6 on the top and the bottom, and the second one will need to be multiplied by 5. So our numerator is just going to be 2x. But on the bottom now, we'll have 6x plus 5x, which is 11x, over a common denominator of 150. So now we have 2x being divided by a fraction. Well, let's write 2x as 2x over 1 and multiply by the reciprocal. And you'll notice that when you do that, the x's are going to drop out, which is great because that means we will get our miles per gallon. And we will need 300 because 2 times 150 is 300 divided by 11. And when you punch that into your calculator, you get 27.27 repeating miles per gallon. Now, like I said, that one fits perfectly with what we were doing with the problem that we had in class and worked together with. Now B, not a perfect match. So here's the issue. Now we have 60% for one and 40% for the other. So we have to figure out which way to use this. And it says 40% in around town, so I start thinking, okay, so 40% of the miles are going to come from around town. And then 60% of the miles are going to come from highway. So plus 0.60 highway miles. Now what that also does is it changes what we're figuring out for our gallons. Because before, our gallons would have been x over 25 for the town plus x over 30 for the highway. But we're only doing this 40% of the time, and we're only doing this 60% of the time. So things just got a little interesting. Our numerator is a little nicer. You know, that's going to be 1x. But now we'll have a decimal within a fraction, which, you know, usually that is really taboo in math. But we're going to go ahead and keep that because we know in the end everything will work out as a decimal answer anyway. So what that means is we have this 0.4x over 25 plus 0.6x over 30. But our denominator, our common denominator that we found last time, is absolutely still going to work. So we're going to multiply by 6 to the 25 to get 150, and multiply by 5 on the 0.6x over 30 to get 150. So we will have x over 6 times 0.4 will give you 2.4x over 150, plus 0.6 times 5 will give you 3x over 150. So that means we have x divided by 2.4x plus 3x will give you 5.4x over 150. And now we want to go ahead and multiply by the reciprocal. So we'll have x, we'll write that as a fraction, as x over 1, and we will multiply that by 150 over 5.4x. X's cancel out, which is exactly what we wanted, and we will have 150 divided by 5.4, and that comes out to 227.7 repeating miles per gallon. So like I said, this is not a perfect fit with what we did in class, but we definitely can tinker with the fact that we know that we have 40% is 0.4 for math use, and then 60% is 0.6 to get what we need out of number 30. Now the next one that I'm going to work through is number 32, which is just add or subtract. So for 32, we need to state the restrictions, and we'll be able to do that once we figure out what that least common denominator is. And we don't have any factoring that we can do here, so that means that both pieces are going to be part of our LCD. Remember, everything has to be there and to its highest power. Well, both of these are to the first power, so that's the highest power. So now what I need to do is I need to build these up and get them that common denominator. Well, my first denominator only has the x plus 1. It's going to need an x minus 1. And again, we have to do whatever we have for the bottom, we do to the top to make sure that we are still just multiplying by 1. We're just manipulating the way it looks. We're not changing its value. And then my second fraction is going to need an x plus 1 on the top and the bottom. And while I'm thinking about it, I'm going to go ahead and write my restrictions right now, because this is my LCD. I know that I'm not going to be able to use 1, and I'm not going to be able to use negative 1. So those will be my restrictions on all of this. And the smartboard froze up for a second. There it goes. All right, so now I'm going to multiply my numerators by distributing. I will get 3x minus 3 over x plus 1 times x minus 1 plus x times x plus 1 distributing will give me x squared plus x over x plus 1 times x minus 1. And again, no new restrictions, because when we found our least common denominator, that's going to give us the restrictions that we'll need for the problem. Now I can go ahead and do the addition. I have a common denominator. Well, I have an x squared in my numerator, and then I have 3x plus x, which is 4x, and then I have a minus 3 over x plus 1 times x minus 1. Now that everything's together, the question becomes, can you simplify this? And that means we now only at the last minute will try factoring our numerator to see if we can cancel something out with the denominator. So there's no common monomial factor to my numerator, and it's not a perfect square. What I'm looking for is two numbers that multiply to negative 3 and add to 4. So two numbers that multiply to negative 3 and add to 4, you start thinking, okay, negative 3, that would just be negative 3 and 1, positive 3 and negative 1. There's no way that that's going to add to 4. So we realize that's not factorable, and we were done, but we did have to check. You absolutely have to check to see whether or not there's any simplifying that you can do at the end of these. In this case, nothing, but we tried. And so, you know, on a quiz or a test, I might even leave what I had, which was, hey, I tried, you know, there's nothing I could do there. There was no factor. And then put a box, star, or circle that answer and write, you know, not factorable up here. Because again, I can't ask you questions while you're taking the test. You need to write out what it is that you want to do. So there is number 32. I'm going to erase this and go back up and look at, I believe, number 33. All right, there we go. Number 33. 4 over x squared minus 9. Now I'm going to go ahead and factor that one right away, because everybody should know by now that is a difference of two squares pattern. And then I need to find my LCD, because my denominators are all factored. Everything has to be there and to its highest power, so I'm going to need an x plus 3, and an x minus 3 because all of these factors are to the first power. Now, I can go ahead and do my restrictions before I get going any farther. Knowing that that's my LCD, I know that I can't use 3 and I can't use negative 3. That will make me divide by 0. Good news, first fraction already has everything it needs for the denominator. The second needs an x minus 3, and whatever we do to the bottom, we have to do to the top. So we have 4 over x minus 3 times x plus 3, and we need to distribute the 7 in the numerator right here, so 7x minus 21 over x plus 3 times x minus 3. Now that we have that common denominator and we can see that denominator is going to be x plus 3 times x minus 3, because remember the order doesn't matter because multiplication is commutative. And we go ahead and add the 4 and the 7x minus 21. So we will have 7x and then negative 21 plus 4 minus 17. And then we stop and think, is there any way to factor that 7x minus 17? There isn't. There's nothing else we can do. So this problem is finished right here. So that one not too bad. You know, we have to use that common denominator, but only one of the fractions required that we build things up. The other one didn't. Now with number 34, really, really, really important that you start by factoring those denominators. I mean, we don't have any idea what's going on with this until we see those denominators as factors. So, pardon me, I'm looking for a greatest common factor for x squared minus x minus 6. It's not there. Negative 6 is not a perfect square, so I look for two numbers that multiply to negative 6 and add to negative 1, and that's negative 3 and positive 2. Now, I see this as subtraction. Immediately, I'm going to change that to adding a negative. And I need to factor x squared plus 4x plus 4. And I look at that and think, well, no common monomial factors, but that's a perfect square trinomial. That is x plus 2 squared, because x squared and 2 squared would give you 2x, and if you double that, you do get 4x. That is the pattern for a perfect square trinomial. Now that's going to help me figure out my LCD by noticing that. I know I have to have the x minus 3, I know I have to have the x plus 2, but I have to have it to its highest power. So that means it has to be x plus 2 squared. My first fraction is going to need another x plus 2. And my second fraction is going to need an x minus 3. And this is, right now, is why it's so important that you change that to adding a negative. Notice that we're going to be changing some signs up there, and that is the most common mistake made in mathematics. So we have 5x times x plus 2. That will be 5x squared plus 10x over x minus 3 times x plus 2, the quantity squared, plus negative 4x plus 12 over x minus 3 times the quantity x plus 2 squared. Again, our numerators, the order doesn't matter down there because multiplication is commutative. Now, we go ahead and do the addition. So we have a 5x squared in the numerator, and we're going to add 10x and a negative 4x, which will give us 6x plus 12 all over x minus 3 times x plus 2, the quantity squared. And now in 34, we wonder, hey, is that factorable? Well, let's check and see. There's a couple of different ways to check and see. The first is to do the discriminant and figure out whether or not it's a perfect square. And remember, the discriminant is just b squared minus 4ac. So a is 5, b is 6, and c is 12. And this is going to give us 36 minus 20 times 12, which is 240, and that's negative, and that's not a perfect square. So this problem is done right here. We have everything that we need. Last thing I'm going to do, so I don't forget, is the restrictions. We cannot use 3, and we cannot use negative 2. There it is. Not exactly pretty, not a lot of canceling we can do there, but still a really good math problem because we needed to consider whether or not something is factorable. And you certainly could, just kind of use trial and error and figure out the factoring, and you'd realize, hey, I'm wasting my time here. Nothing is going to work. Number 36 is kind of an interesting problem. We have to do some subtraction and then some addition. So again, incredibly important that we change that to adding a negative. So we have 5y, pardon me, and we'll go ahead and factor our denominator. So y times the quantity y minus 7 plus negative 4 over 2 times the quantity y minus 7, and you kind of get a feel for how that denominator is going to come into play, and then 9 over y. So LCD time. Everything has to be there and to its highest power. So we need a 2, that's the number part. We need a y, that's the variable part, that's all by itself. And then we need our binomials, and that's y minus 7 to the highest power, and those are both to the first power. So there's our LCD, and that means y cannot be 0 and y cannot be 7. That'll be our restrictions. So let's build them up. The first one has the y minus 7, but it needs a 2. Whatever you do to the bottom, you have to do to the top. Second one has the 2, and it has the y minus 7, but it needs another y. And then the last one just has the y. So that's going to need a 2 and a y minus 7. So make sure you keep track of all of that. So the first fraction will become 10y over 2y times the quantity y minus 7 plus negative 4y over 2y times the quantity y minus 7 plus, well, this will really be an 18 that we're going to distribute through here because 9 times 2 is 18. So 18y minus, and then we just need 18 times 7, and that's going to give you 126 all over 2y times y minus 7. We can absolutely see our common denominator at this point, our least common denominator, and we also see that it's time to do our addition. We have everything that we need lined up once we have that common denominator. So now it's time to go along the numerator and combine any like terms. So we have 10y plus a negative 4y, which is 6y. 6y plus 18y is 24y minus 126 over 2y times the quantity y minus 7. And right away I notice, hey, both of those are even. I can definitely take a 2 out of that, and that'll cancel with the 2 on the bottom. So let's give that a try first. Let's take a 2 out, and we would have 24 divided by 2 is 63. Oh, 24 divided by 2 is 12. And then 126, pardon me, divided by 2 is 63. All over 2y times the quantity y minus 7. So the 2's cancel out. And we get to this point, and we have 12y minus 63 all over y minus 7. So we start thinking, hey, wait a minute, 3 goes into both of those. Is there anything bigger that goes into both of those? There's not, but we try it. So we pull out a 3, and we say, all right, that's going to be 4y minus 21 times the 3 all over y minus 7. But we realized that was kind of futile because there's no way we're going to get a y minus 7 out of that so that we could do any canceling. But again, we still have to show, hey, I knew to try. You know, I knew to go ahead and keep going with my factoring as I went through here. And we have our restrictions already up there. Next piece here is think about a plan. For the image of the overhead projector to be in focus, the distance d sub I from the projector lens to the image, the projector lens focal length f, and the distance d sub 0 from the transparency to the projector lens must satisfy the thin lens equation. There it is right there. 1 over f equals 1 over d sub I plus 1 over d sub 0. what is, or maybe it's d sub o, it doesn't make any difference. Usually d sub 0 is what we're going to use in science or in statistics to talk about the original distance. What is the focal length of the projector lens if the transparency placed 4 inches from the projector lens is in focus on the screen located 8 feet from the projector lens? Oops. Inches, feet. Can't let that get past us. Let's put them both in inches. So there we go. So now what we need to do is we need to throw that into the formula, and we're looking for 1 over f. And we need that d sub I, which is, in this case, remember we had the focus on the screen located 8 feet from the lens. And that's d sub I. So that's going to be the 96. And then the last piece would be the original right there. Now, this is kind of interesting because this is actually in the wrong section. I mean, if they just wanted us to leave it like that, this would be a good problem for this section. But what we're actually trying to do here is solve. So we would want to figure out, what's our least common denominator here. And the LCD is going to be 96F. So, pardon me. The first fraction is going to need a 96. This one's going to need an F. And this one, 24. So we will get 96 over 96F equals 1F over 96F plus 24 over, oops, forgot an F, 24F over 96F. There we go. All right, now don't go backwards. Don't start canceling anything. Remember, we did all of that so we could get a common denominator. So now if you're saying, well, now what do? I do have a common denominator. Well, we don't need our common denominator anymore, because if this is going to be true, the denominators are already all the same. What we have to make happen is 96 is going to have to equal F plus 24F. Absolutely has to equal that. So 96 is going to have to equal 25F, and then we'll take 96 and divide that by 25, and we get 3.84 for the F value. So like I said, that's not necessarily the best fit for this section. We're actually going to go into the solving in section 8.6, but we'll do what we have to do when they throw it at us. All right, 43, nice little complex fraction here. So what we need to do is focus on the two parts to this, and the two parts are the numerator and the denominator. I'm going to work on my numerator first. I need that to be 1 fraction. So if I'm going to get that to be 1 fraction, I want to change this to adding a negative. And I have to find my LCD. For the numerator, I'm going to need an x and I'm going to need a y squared, because these are both to the first power and you take everything and to its highest power. So that means this one will need a y. And this one is going to need an x. So now I will have, across the top, 1y plus a negative 1x, which is really y minus x, over my common denominator of xy squared. That is my numerator. Now I have other math I have to do, so I'll come back to that one in a little bit. Now I need to go after my denominator. And that one is 1 over x squared y minus 1 over xy squared. I need my LCD. My LCD, I'm going to need an x, I'm going to need a y, and I need it to the highest power. So in this case, I'm going to need an x squared and a y squared for this one. So my first fraction already has the x squared, it needs another y. My second has an x and a y squared, it needs another x, and I'm going to go ahead and change this to adding a negative so that I don't make any mistakes. And I see across the top there, I'm going to have that y minus x again, And my denominator will now be x squared y squared. That is my denominator. Now I can't forget that what I have to do is divide these two. So I'm really going to take y minus x over xy squared, that was my numerator, and I'm going to divide it by my denominator, y minus x over x squared y squared. And that means I'm going to be multiplying by the reciprocal. So y minus x over xy squared times x squared y squared over y minus x. And I hope you saw that coming as we went through this, as you think about your division. So the y minus x's are going to cancel out. We can cancel out one of the x's, and we can cancel out both of the y's. And very cool answer there of just x. That's it. So pretty cool. They didn't ask us to state restrictions on the variables, but x can't be 0 and y can't be 0 on that one. Then, number 45. This one, I guess I wouldn't even really mind if you just used your calculator for this one, because this is going to be just flat out numbers when you get this done. They've got a lot of blah, blah, blah up there, but basically what they're saying is put this in for A, put this in for B, and figure out what you get. It's talking about harmonic mean of two numbers, and like it says, as you vary the length of a violin or guitar string, its pitch changes, obviously, or it would always sound the same. If a full-length string is 1 unit long, then many lengths that are simple fractions produce pitches that harmonize or sound pleasing together. The harmonic mean relates two lengths that produce harmonious sounds. Find the harmonic mean for each pair of string lengths. So we would have this be 2 divided by 1 over 1 plus 1 over 1/2. Well, that will be 2 over, 1 divided by 1/2, that's just the reciprocal for 2. So this is really 1 plus 2 down here, which is 3. So that one is 2/3. And then you'll go through and do the rest of these exactly the same way. So for B, we have 2 over 1 over 3/4 and 1 over 1/2. That will give us 2 over the reciprocals of those, so 4/3 plus 2, and you can put 2 over 1 if you want to. We are going to have to figure out what that fraction is. So 2 would be the same thing as 6/3, and we would have 4/3 plus 6/3, which would be 10/3, and then we'd go ahead and multiply by the reciprocal, and you can do a little cross reducing here, and get 3/5 for B. And I might as well go ahead and do C and D while I'm here, I suppose. I was going to stop and just have you finish these up. But we have for C 2 over 1 over 3/4, which we already experienced, plus 1 over 3/5. So that will be 2 over the reciprocal of 3/4, which is 4/3, and the reciprocal of 3/5, which is 5/3. So now we can go ahead and add those two together. We'll have 2 over 9/3, which is just 3. And we get 2/3 again for C. And then last but not least, we have D here. And that will be 2 over 1 over 1/2 plus 1 over 1/4. So we will get 2 over the reciprocal of 1/2, which is 2, and the reciprocal of 1/4, which is 4. So that will be 2/6, which is 1/3. And again, you could just use your calculator for this one since it is just numbers. All right. For problem number 59, we are looking at some composition. And composition, remember, is putting one function inside another function by substitution. But in this case, because we're going to analyze this for one number, we're going to evaluate this, what we can do is we could take the -3 and put it into the function f. So that will be -3 squared plus 1. Get an answer for that. -3 squared is 9, and 9 plus 1 is 10. And then take that answer and put it into the function g. And g is 3 times x. Well, we're going to put that 10 right here. And 3 times 10 will then give us 30. So that would be the answer that we need for number 59. Now, the other way to do this problem would be actually do the composition. So take f and put it into g. Take this and put it right here for x. So 3 times x squared plus 1, that would give us 3x squared plus 3. Now, we are supposed to put negative 3 into this function. So 3 times negative 3 squared plus 3 will be 3 times 9 plus 3, which is again 30. So 2 different ways to get exactly the same answer, dependent on whether or not, if this is multiple. Problem number 65 is a really good lead-in to what we're going to need in the next section. And that has to do with the fact that if you have fractions in an equation and you don't want to deal with the fractions, what you need to do is multiply all of the fractions by the least common denominator. And we see here that for 2, 3, and 1, because 15 is the same thing as 15 over 1, that LCD would be 6. So we're going to multiply each of these fractions by 6. But here we could do a little reducing, and that will give us 3x. Here, if we reduce, we get 2x. And on the other side, of course, we just have to figure out 15 times 6 is 90. And then we'd have 5x equals 90, and we would divide both sides by 5, and we would get x equals 18. And if we check that, we'll have 18 over 2 plus 18 over 3 equals 15 back in the original. Well, this is 9 plus 6 equals 15, which is absolutely true.